Pinpoint asteroids in orbit, then hurl y'all thousands of miles an hour towards it.
All right, welcome. This is Earth is Life, and what we're going to do today is we're going to use Space Engine to make some predictions. So, this year, 2025, there are going to be 4 eclipses. There are going to be 2 solar eclipses and 2 lunar eclipses, and we're going to use Space Engine to predict those eclipses. So, what I love to do is I love to use Space Engine because it is a perfect tool for making predictions because, if the Earth wasn't a sphere, we wouldn't be able to make these predictions. So, Space Engine is based on a globe, and it's based on our heliocentric model. So, according to the globe model, on March 13th, there's going to be a lunar eclipse in North America. So, what we're going to do is we're going to change the date here to March. Let's see, March, which is going to be 13. And I pulled up these dates off of timeanddate.com. So if you want to go and check them out, you can. They are the lunar and solar eclipses that are going to happen this year. So let me see, 13. So boom. Okay. And this is going to be visible in somewhere in North America. All right. So let's see. All right. So here's North America here. It's nighttime. Okay. And we're going to go somewhere in let's go somewhere. Let's go somewhere in Mexico. Let's go like central Mexico somewhere. Right down here. All right, I think I'm on the ground. Okay, let's move up and we're gonna search for the moon. All right, so where is the moon? Boom. Okay, moon is right there. Now, we're gonna zoom in on the moon and we're gonna track the moon. Boom. Now, what we're gonna do is we're gonna play and we're gonna let the clock run and we're gonna see exactly if this model will predict that we're going to see a lunar eclipse on this particular date. All right, so let me just go here and we're going to speed up time. Oh, so we're underground. I might have to reverse. Oh, there it was. Okay, so let's go back. So that blue you see that's the eclipse. First of all, let me turn the filter on because I have a filter on. Let's turn the eclipse total mask filter off. Okay, X. So it's going to be on the 14th. So as you can see, Space Engine has made this prediction. Let's slow that down. Come on, get out of here. Let's slow that down a little bit. All right, and let's back it up. Reverse. Here's the eclipse. Boom. So according to this model, which is based on a globe, on this day, this is what the eclipse is going to look like from central Mexico. Let's zoom in a little bit. Let's see if we can see that a little bit better. That's the moon. All right, let's play again. Let's reverse. There's the shadow of the Earth. And there it is. So this model has made this prediction. So let's see on those dates if it actually comes true, which is March 13th or March 14th, whichever one of those days. All right. So now the next one is going to be March 29th, which will be a solar eclipse. So let's zoom out here. Let's change the date. Let's go back to now. Let's change the date to March 29th. 3, 29th, hit enter. Okay, so let's get off the surface of the Earth. But first, let's not track the moon anymore because we're not looking at the moon. Let's get off the surface of the Earth. There we go. There's the Earth. Yes, it's a sphere. And this is going to be visible. This one is supposedly going to be visible in somewhere in Canada, northern Canada, so that we can see where it's actually going to happen. Let's go ahead and move time. Let's speed it up a little bit. And we should start seeing a shadow over here. Oh, there it is. Boom. There is the shadow. That is, let's see, where is that? Yeah, that's Greenland. Or no, that's Greenland. Iceland's here. This is Greenland. This is northern Canada. So let's go ahead and let's zoom out a little bit. Okay. Slow down a little bit. So there it is. Now let's see what it's going to look like from the surface. So let's go here. Let's go down to the surface. See if we can get right in the center. The closer you are to the center, that's the closer you are to the path of totality. All right. Now, where is the sun? All right, what? Let's kind of lost our bearings. So let's get back off the surface. So I can't see where I'm at. Yeah, let's go about right here. Oh, excuse me. All right, let's find the sun. Where is the sun? Okay, let's go ahead and search for it. Sun. Okay. Let's go ahead and change time here. Where am I zoom in? What am I doing? Where am I? Oh my goodness, I'm all over the place. Where? Hold on a second. Pause. There it is. Hold on one second. Let's let's zoom out. Am I zoomed in or zoomed out? Oh no, what am I doing here? Oh, I'm underwater. No wonder. Here we go. Okay. I was underwater. No wonder. Okay, let's do this again. Let's go back. Let's play and let's reverse because we're on the 29th, right? 28th and 29th. There we go. Let's pause. Okay, let's see. Let's see. So this is when you kind of have to search for it. All right, let's see. Let's play. Let's reverse. Let me see. Maybe it might. Should be around sunrise. Oh, there it is. Boom. Let's check it out. Let's zoom in. There it is. Oh, so that's right after sunrise. That's cool. That's pretty cool. So right after sunrise on this day, let's hit the Let's hit play. Let's reverse. Yep, here it is. So right after sunrise, that's when it should start. And this is from northern Canada. Look at that. So again, according to this model, this is what we should see on that day at that location. Now, I don't think anywhere on Earth for this eclipse, you're not going to be able to see a total eclipse anywhere because the shadow is off of the surface, the main shadow. So let's try this right here. Let's zoom in again. All right, let me zoom out just a little bit. All right, and let's see. See, I think if I get off the surface, I'll be able to see a total eclipse, right? See, I'm off the surface. If I go up, yeah, you'd have to be in space to actually see a total eclipse because the Earth is only skimming a portion of the shadow of the moon. That's why you're not seeing. That's why there's no place for this one. There's no place on Earth where you'll see the full eclipse. All right, let's go back down to the surface. Yeah, and let's get out. Let's go up. Yeah, there is the path of totality right there. Let's let it play. Yeah, it's barely skimming a portion of that shadow. That's why you're not going to get a total eclipse for this one. Yeah, see? Let me see. Let's go over here. So this is in Greenland. What are we going to see from Greenland? If we go right here in Greenland, just off the coast of Greenland. Make sure I'm not in the water again. Yeah, same thing here. Just off the coast of Greenland. That's where you're going to see. Yep. So again, based on this model, this is what we're going to see. Well, if anyone is in those locations, this is what they're going to see on those days. Okay, so the next one is going to be on September 7th. So let's change the date. So 09 and 7. 07. Boom. Okay, and this one is going to be visible in India, and it's a lunar eclipse. So we're going to have to wait till nighttime. Let's go off the surface. Okay, now let's go to India. We zoom out. Oops, I'm too far zoomed in. There's India right there. And let's go down to the surface somewhere, anywhere in India is fine. And we'll have to search for the moon. Okay, apparently the moon is below our feet. And let's change the time. Oh, we have to speed this up. This is going too slow for me. Too slow. But let's track it. No, no, not that way. Oh man, where's the moon? Let's not lose it. Okay. Boom. Speed up. Okay. There we go. Now, let's see if we can zoom in and then track it. Well, this is on the 6th, so we're gonna have to go a day further. So reverse. But first, let's track it. That way we don't lose it. Let's track. Okay, play. It's gonna go down below the surface and slow it down. Let's zoom in. There it is. There's a lunar eclipse into the shadow of the Earth and comes out of the shadow of the Earth. Look at that. I mean, it's just like the model predicted. Yeah. So again, based on this model, which is a globe space engine, on this day is going to be a lunar eclipse visible in India. Anybody wants to try and verify that? Well, we'll see. We'll see what happens. All right. Now, last one will be a solar eclipse. Funny enough, it's going to happen in Antarctica, our favorite place. So first thing we're going to do, we're going to untrack this. Yeah, I don't think we're not tracking anymore. Are we still tracking it? No. Let's get off of that. No. All right. So this one's going to be, let's zoom out. Let's get off the surface of the Earth. This is going to be in Antarctica. And according to the prediction, it's going to be somewhere between it's going to be in the water between New Zealand and Antarctica. So we're going to do this right here. That way we can get in the right spot. Boom. So somewhere in here, right? So let's change the date. It's going to be September 21st. 21. Boom. Okay. Now let's see. See what happens. There it is. Slow it down. There it is right there. Boom. Did you see it? Did you see it? Did you see it? Right there. There's a shadow. Again, this is the same one where you're only going to get only a portion of the Earth is just skimming across that shadow of the moon. Just a slight portion of it. So let's see what it looks like from the surface. Let's go down to the surface. Oh, let's hope they're not. Oh no, what am I doing? There we go. Let's go back. Let's go down to the surface. Where is the? Where am I? Oh, I'm lost now. I'm lost. Okay, there we go. Okay, so there you go. You can see right away. You can see that the moon is eclipsing the sun. Again, this is September 21st. Let's do this. Let's track the sun this time. Track. Let's change time, speed it up a little bit. Oh, slow it down. There it is. That's a partial eclipse from Antarctica. Now let's see. Again, so same thing as before. Like I said, you're not going to get a total eclipse because the Earth is just skimming across that small portion of the shadow. So nowhere on Earth are you going to see a total eclipse on this day. But again, the model predicted this. According to the globe, which is according to the space engine, which is a globe, on this day, in this location, at this time, there's going to be an eclipse, a partial eclipse. Let's zoom out. Yeah. Now, this is just a testament to the the predictive power of the globe model. There's nowhere has there ever been a discrepancy when it came to an eclipse on a wrong day or at the wrong time. It's 100% accurate all the time. Now, give or take a few minutes or so, but no matter what eclipse you pull up using Space Engine, it's always going to be accurate every single time. All right. So, am I still tracking this? Let me make sure I'm not tracking that anymore. Let me zoom in. Yeah. Yeah, let's not track the sun anymore. Okay, let's zoom out. Now, another thing I like to point out. You see this horizon here? So, on the surface of a globe, we would absolutely expect the horizon to look flat. No matter how far you look, it's going to look flat no matter what. So, on a surface of the Earth, on a sphere the size of the Earth, the horizon is always going to look flat, no matter what. But what happens when you get higher is that's when you start to see that curve. It's right there. So, flat earthers, there's the curve you're looking for. It's right there. Yes, this is Space Engine. Yes, it's only a computer program, but based on this, on the surface of this globe here, it's going to look flat when you're on the surface. But that's all I wanted to show. Again, if you made it to the end, I appreciate you watching. Don't forget to like, share, and subscribe if you like this video. And check out the rest of my videos if you're interested. And as always, peace.
Pinpoint asteroids in orbit, then hurl y'all thousands of miles an hour towards it.